All right, so what's our initial setup? Well, so first we've got to put supply and demand. So we've got a downward sloping demand, and then we've got a upward sloping supply curve. Where they meet is our equilibrium. Well, what? We got to label the axes. So that's where we start. And so we have some information going on here, right? In terms of the study that cereal is bad for you.
So that would drive the demand down, right?
Yes. So that would be a what? A left shift or a right shift in your demand? Left. So driving the demand down, also known as a leftward shift in the demand curve. Very good. And so now the new equilibrium price and quantity is going to be lower than we saw before, correct? Does that make sense, everybody? Now, the next one is a little bit more difficult. Why is it going to affect the supply curve?
Because a piece of the cereal is going to be more expensive than one, just less.
And so it's what we would call a complement in production. So this is probably the trickiest one of all, right? Complement in production. And so the supply curve is going to shift down, or another way to think of that is a leftward shift. In the supply curve. So what does that look like up here? This is our supply one. We'll leave this demand shift. So what if these both happen at the same time? Right? What's going to happen to equilibrium price and quantity? So what I always do whenever I have a simultaneous shift, right? When there's something that's happening with demand and then something that's also happening with supply, I try and make them about the same distance apart, okay? And there's a reason why I do that. So then I'm gonna make this one right here, S2. And so now let's look at the latest equilibrium quantity. I'm gonna use a dark blue just because we've got a lot of stuff going on, right? So S2 and D2 is gonna be right here. And so what's happening with quantity? We know that from quantity, from the first equilibrium to the second equilibrium is going down, and then to the third equilibrium is also going down, right? Q star to Q double star to Q triple star. Down, down, down. But what happens with the change in the price? We actually don't know. We don't know, and we can't actually figure it out. And so that's, so again, why did I do both of these shifts around the same amount, right? This, you know, I would say that this is like 1 unit, and then the same thing going on here. Why did I do that? Because then the equilibrium price looks like it's the same exact equilibrium price as when we started out. And that is a huge red flag to me. Right? If I ever have a double shift and it seems like something is the same price, what's actually happening is I have no idea what's happening with that one. So you'll definitely know something's going on with the quantity. Like you'll definitely know something's going on with one of them. And so if both of these are happening together, then we end up with a quantity decrease and a price. Oh. And that's the answer. That would be the multiple choice answer, or that would be what you would write it. Does that make sense to everybody?
And that applies to whenever there's a double shift.
Whenever there's any kind of double shift. Right. So real quick, let's just do another practice, and then we'll jump into some new material. Everybody got this? Any questions on this example? This is really tricky. So why is the supply going down? Because at any given price, the suppliers are going to be supplying less because the thing that people were buying it for, the complement in production, the price of that has gone up. So since the price of something has gone up, that's a complement of production, the supply is going to go down. So here, that's the hardest one. Let's do an easy one now. Let's do, what should we do? What's something that somebody bought over the weekend? I bought a teddy bear. All right. And so let's have a double shift. And so we're going to say that one, the number of children increases. And then the second thing that's going to happen, cotton becomes cheaper.
Cotton as in the material, or like the polyfill?
The polyfill, yeah, sorry. Polyfill. No, thank you for the clarification. All right, so first thing we got to do is get a downward sloping demand curve, upward sloping supply curve, equilibrium, price and quantity, P, Q, there goes all my papers. So what happens when the number of children increases? Demand would increase, very good. That's going to shift out that way. Demand 2, demand 1. Okay, so what happens to equilibrium, price, and quantity? Increase. So when the new X meets the spot, that's going to be P double star and Q double star. And then what about cotton becoming cheaper? Polyfill becoming cheaper, rather. Demand or supply? Supply. Is it increase or decrease? Increase. So is that a shift which way? To the right. Very good. So again, you got to be really careful about supply. It's easy to think, oh, an increase means a shift up, which is a shift to the left, but an increase in fact means a shift to the right. And so when we do a shift to the right, again, I just went ahead and I did that space the same, right? And the reason why I did that is because then it's going to be really clear to me that one of them, right, the Q triple star, it increased and now it's increasing again. but then it looks like the price is exactly the same as it started out. Wait a second, that's my red flag, right? I don't know what the change in the price is when I have a double shift increase, right? So when I have an increase in demand and an increase in supply, that means that I'm going to get an increase in the quantity, right? But I don't know what happens to the price. So why don't we know what's happening to the price? So here, let's take a look down at the bottom real quick. So let's try a few different ones. Price, quantity, price, quantity, price, quantity. Let's have it so that the demand is shifting huge and the supply is shifting normal. Well, then we end up with an initial P star, Q star right there. And then the next P star, Q star is over here. So from that, it looks like both of them increase, right? Does that make sense? Now let's try if we have a large supply increase and a normal demand increase. Oh. Yep. So now we have, then here's our initial P star, Q star, and our next one, P double star, Q double star. So this one looks like the quantity increases. It looks like the price decreases, right? What's going on there? And then it's not even just the size of stuff that's important. It's actually also the slope, right? So let's say I did a really steep demand curve. And kind of a normal supply curve. Well, this is not the best job, but it's still, it'll give you that kind of false, right? P star, P double star, Q star, Q double star. So the only thing that's constant in all of these is the fact that quantity is increasing, right? This one price is increasing, this one price is decreasing, this one price is increasing, right? So you gotta make sure that you can't draw the curves in some other way to make it so that the price increases, increases or decreases. So like okay, what am I saying? In actuality, we don't know what's happening with the price, right? We can draw it in such a way that it looks like it's increasing, it looks like it's decreasing, it looks like it's increasing. Every time, though, the quantity increases in all these graphs. So that's one of the things we do know. And that's why I draw the graphs equal, the slopes are equal and the sizes are equal so that it looks like the price or quantity, whatever the case may be, is exactly the same. So when you see that it looks like it's exactly the same as what it was before, that's a big red flag, and you should think to yourself, oh, it's a double shift. One of them is what we call ambiguous. It's unknown. So when only one curve is moving, how many, can you figure out both the price and quantity? Yes, both of them. But when two curves are moving, you'll only figure out one of those things in terms of does the price move or does the quantity move in what direction. Does that make more sense? Some of you aren't getting it still? Yeah? I see some confused look. Let's try a little bit of practice before we move on. Well, let's just do some practice about how the supply chain, the supply curve, not chain, moves. So real quick, how will each one of these things affect the supply of auto tires? All right, so of auto tires, supply of auto tires. So the first thing is a technological advance, so that it's not so blurry, in the methods of producing tires. What do we think is going to happen here? Increase or decrease in supply? Increase in supply, which again is just a shift out in the supply. So if we do the demand, supply 1, supply 2, we see that the price decreases and the quantity is going to increase, right? So the new, and when I say the price is increasing and the quantity, or price is decreasing and the quantity is increasing, I'm saying the new equilibrium price and quantity, right? So it's again, it's not guaranteed, it's just saying, you know, it tends to happen. What about if there was a decline in the number of firms in the tire industry? What's this going to do to supply? Increase or decrease? Decrease supply. Very good. All right. What about the expectation that the price of tires will be lower in the future? Put your supplier hat on. If you think that the price of the tires is going to be lower in the future, exactly. Very good. Yep. You're going to increase your supply right now. Let's move on. I think we're good on this. Numerical stuff. Okay. How are we on shortages and surpluses? I know we went over that quick. Did you guys have any problems with that? No? Good? Okay. Let's move on. All right, so let's get into chapter 4. All right, so what's our formula for elasticity? It's the percentage change in the quantity demanded divided by the percentage change in the price of a good, right? And what do we know about elasticity, right? That elasticity falls on, a number line, right? It's going to be, so can it be negative? But usually we have what do we do? We do absolute value of these things, right? So it ends up always being greater than 0. So here, so it's 0. And whenever it's the elasticity of demand, we know that, so yeah, we end up just putting absolute values, it's greater than 0. And so it ends up falling between greater than 0, it could be 1, or it could be greater than 1. So let's talk about these 3 ranges. So between 0 and 1, this is called what? Inelastic. Very good. Inelastic. If it's greater than 1, what's it called? Elastic. And if it's exactly 1, what's it called? Unit elastic. Very good. So inelastic. How do we remember inelastic? What is the awesome mnemonic? What also starts with inelastic that's super inelastic? Insulin. Insulin is very inelastic, right? Why? Because there's a very small percent change in the quantity demanded if, or regardless, of the percentage change in price, right? Doesn't matter what happens to the price of your insulin, you need it, otherwise, if you're diabetic, you're gonna die. So it's very inelastic. What about elastic goods? Elastic good is something where if the price changes, I'm going to, I'm not going to buy it at all anymore, essentially. So, a lot of our luxury goods or whatever are inelastic. Red meat. If the percentage change in the price is large enough, I buy less. So it might not be red meat to you, it might be yogurt, it might be soda, it might be Cheez-Its, whatever. Could be movies, it could be drinks, it could be trips to, it could be car trips, right? As the price of gas increases, it'd be like, can't go to Rapid anymore, it's too expensive now. So it's different for everybody, and it's different for when we're thinking about different time periods. So at the end of the day, it really is just the consumer's responsiveness to a change in price. Right? Does that make sense to everybody? Why are we using these weird percent changes? Why don't we just use just the change in price? The absolute change.
Because we need to be able to. It's like if the price of ramen noodles goes up, that's a lot different than the price of Tesla. $100,000.
Right, or if the price of ramen noodles goes up $1, that's a lot different than the price of a car going up $1 or something like that. Or the price of a beer going up $1 is a lot different than the price of, an airline ticket or a tractor or a four-wheeler or a gun or whatever, right? And so we use the relative change in both the price and the quantity instead of just the absolute change. So a lot of us are used to, I almost went into a accent there. A lot of us are used to, when we have these percent change formulas, to do new minus old over old, right? So we had percent change. We said, okay, percent change in X is equal to new minus old over old times 100, right? That's the typical formula that we all learned for percentage change. That's now what we're using. You're like, well, then why did I write it down? Well, because we're used to that. What we're actually going to be using now is a midpoint formula, okay? So percentage change in quantity demanded is equal to the quantity demanded 2 minus the quantity demanded 1 over the midpoint. So then I'm going to add them up. Quantity demanded 2 plus quantity demanded 1 over 2. So real quick, on your own, calculate the percentage change in the quantity demanded as I go from consuming 2 units to 3 units. What's that in percentage change? Using the midpoint. So I'm at 3 now. I was at 2. So my Q2 is 3 minus 2 over 3 plus 2 over 2. That makes 1 over 2.5. Yeah, times 100. So whatever that is, 2.5. 1 over 2.5 times 100 is going to be 26.6 repeating percent. That make sense to everybody? All right.
So I have like the world example of that.
Yes. That I'm working on it right now. All right. Dropped on my paper. Okay, you guys ready? So when the price is $7 a month, block sells. Still getting used to this thing. So when the price at $7, they sell 500 bottles of perfume. An increase in resource costs means that prices have now gone to $9, and now they're only selling 460 bottles of perfume. What's the price elasticity of demand? So again, what's the formula? It's percent change in the quantity demanded, absolute value, over percent change in the price. Absolute value on the bottom. Exactly, yep. Anybody get an answer yet? Okay, so that's a great point. All of these numbers are going to, like, if you don't do the absolute value, you should get a negative number. Why? Why is that? Because of the law of demand, right? So the fact that it's downward sloping, as we decrease the price, right? As we decrease the price, which is a negative percent change, we're always going to get a positive percent change in the sorry, that's right, positive percent change in the quantity, right? And vice versa. If we increase the price, less people are going to buy it. So one of these is always going to be negative. Does that make sense? Just because of the law of demand. So if we go from this price, you know, if we go from $3 to $2, then instead of 4 people wanting it, there's going to be 6 people that now want it. And so this is a positive change of 2 out of 5%, right? Times 100 percent is the positive percent change in the price. And then this is a negative change, or sorry, quantity. And this is a negative change in the price from 3 to 2. And so that would be 2 minus 3 is negative 1 over 2.5 times 100. And so that's, again, the negative percent change in the price, right? So one of them is always negative, one of them is always positive. That's why we put the absolute value around them, and then it always ends up being a positive number. But we know how to interpret it because of the law of demand. Just think about, like, how do I behave when things are cheaper? I buy more of it. When things are more expensive, I buy less of it. It's an inverse relationship. So if you get a negative number, that's fine. Just drop the negative and it's going to be fine. So is it inelastic or elastic? It's less than 1, first of all. You sure? Anybody get that?
I converted it to a percent. That's why.
Oh, sorry. Yeah. So both of these are percent. And so this is actually a great question. What's the unit of an elasticity?
No, percent.
It's unitless. Because you have, so here, we have a something percent in the numerator, right? We have, you know, x percent. And then we have another percent in the denominator. So the percents cancel themselves out. And so elasticities are unitless. So why is it, how can it be unitless? Because it's talking about a relationship. So it's not giving us a measurement like, you know, how long is this thing? It's 2 feet. Or how much does this weigh? It's 7 pounds. So elasticity is telling us how 2 things relate to each other. So since it's not giving us anything like in reality, in physical space or something like that. It doesn't need a measurement. Does that make sense? So it's unit lifts. So it's less than 1. Yes. So how is it 0.33? How is it less than 1? Let's walk through that right now to make sure that everyone can get there. All right. So this is going to be my what is it? My Q1 and P1. This is going to be my Q2 and my P2, right? And so I can rewrite this if I want to, and it's 500, 7, and then it goes to 460, 9, right? And then I'm going to get my percentage change in the quantity demanded first, right? So these are my prices over here. So these are quantity and price. Cool. Everybody with me so far? So then we have percent change in the quantity is equal to, and so this is my Q2, this is my Q1. So I'm going to have 460 minus 500 divided by 460 plus 500 over 2, and then all of this times 100. So we end up with what? We end up with negative 40 in the numerator. We end up with 480 in the denominator. Negative 8.333% for my percent change in the quantity demand. Very good. Now let's go ahead and do percent change in price. Let's change up on mine. So percent. Nope. Because as long as you keep the pairs together, then when you do the price, that one's going to be negative. Does that make sense? And again, at the end of the day, it doesn't really matter because you're going to take the negative away, right? But yeah, you just want to stay consistent. Okay, so then percentage change.
The percentages cancel each other out. Do you have to
No, you can just leave the hundreds out. Yeah, I skip this step all the time. But for completeness, I taught this many times, and so students get upset. But yeah, you can just drop it. It's on the numerator and denominator. Yep. So the percentage change in price is going to be 9 minus 7 over 9 plus 7 over 2 times 100. So we end up with 2 over 8 times 100, yep, which is 1 over 4 or 25%. So the change in price, percent change in price is positive 25% flat. Sweet. Got to put them together, right? So my elasticity is my change in the quantity demanded, absolute value, over my change in the price, absolute value. And so we're going to end up being absolute value negative 8.33 repeating over absolute value 25. And so that ends up being 0.333 repeating. And so since this is less than 1, that means that it is inelastic. Make sense, everybody? This was bottles of perfume. It's just the end of the chapter. Question. Bottles. Okay, so we've got 2 more concepts to cover in elasticity before we are done. I'm going to skip the elasticity of supply. But I'm not going to test you on that, so you can just skip that. Don't worry about it. But very important, we have to talk about the elasticity of income. Because we already talked about it a little bit in terms of what is normal and what's not normal, right? The ramen noodles, bus tickets, and then everything else. But we have to actually define it, right? So the income elasticity of demand, you could just say income elasticity of demand. This is my percent change in the quantity demanded. Ooh, actually. Not absolute value, sorry. It's very important to not absolute value this. And then my percent change in my income. So, you know, if I say that, you know, when you were making $30,000 a year, you purchased 15 packets of ramen noodle a year, and when you make 60,000, you only purchase, you know, 5. Is ramen noodle a normal or an inferior good? And so how do we figure this out? Well, if it's a normal good, then the income elasticity of demand would be positive. If it's an inferior good, then the income elasticity of demand is going to be negative. So let's go ahead and calculate that on our own and answer the question, is ramen noodle, according to this data that I collected about myself, is it normal or not, or inferior? What do we get? Negative number? Inferior. So I got 2. So change in the quantity demanded was -1. And then the change in the income was positive 0.66, right? Positive 66%. So 1 divided by that gives you like negative 1.5. Does that make sense, everybody? If you have trouble with that, send me an email and I'll make a video, or come to office hours tomorrow. I'll have office hours from like noon to 2. Okay. So really quick, just a couple of notes. The industries that are the most income elastic are the hardest hit during recessions. Does that make sense? So, something that's low income elasticity, good. Food, right, has more of a stable demand. Than something with a high income elasticity. Like movie tickets, vacations, new TVs or video games, right? Make sense? All right, and our last type of elasticity that we have to know is cross-price elasticity. So this is the percentage change in the price of good X divided by the percentage change, or sorry, the quantity of good X divided by the percentage change of the price of good Y. So how can this pan out? Well, if it's positive, then the goods are substitutes. If it's negative, then they are complements. And if it's 0 or around 0, then they are unrelated or independent. So if the cross-price elasticity of demand for coconut and fruit punch is 1, what would that mean? For coconut, milk, and fruit punch. That they're substitutes. As the price for one of them increases, the quantity demanded of the other one increases. So, almonds and pecans they have a positive cross-price elasticity, right? If the price of an almond increases, you just buy pecans or you buy pistachios or something, right? You know, the price of soy milk and regular milk. What about things that are negative? Let's think of some complements.
Salad.
Salad and salad dressing. Very good. Mm-hmm. Or eye watches and eye watch bands, right? Fit, and fit, band. You know, socks and shoes. Peanut butter and jelly. There you go. Hot cocoa and marshmallows, right? So, I think, true. The ingredients for smush. And then, you know, completely unrelated is, you know, going to be like pickles and windbreakers. You know, like you're not gonna find anything related there. Now, this would be a great break to show you guys one of my favorite websites called Spurious Correlation. Yes, absolutely. So this is fascinating facts that are very correlated, but obviously unrelated. So U.S. spending on science and suicides by hanging. Number of people drowned falling in the pool, number of films Nicolas Cage has appeared in. Cheese consumption. There's a lot of dyed stuff in here. It's a little macabre. Divorce rate, per capita consumption of margarine. It's very correlated, 99.26. Nothing to do with each other, obviously, right? And so we don't want to just be tricked by, you know, just the numbers, right? And so, yeah, so I like this website a lot. Spurious correlations. Revenue generated by arcades, computer science stock. I mean, there could be something there, honestly. The more nerds you got playing arcade games, the more computer science stock. You know, not all of them are terribly spurious. Okay. Okay, and the last thing, and I suppose we can get going, is the relationship between the elasticity of something and its total revenue. So this is my total revenue. This is price. This is the quantity. This is my quantity as well. And so in any demand curve, there's going to be a point on it where it's unit elastic. So we tend to think of certain goods as inelastic or other goods as elastic, right? But what actually is happening is every demand curve for every good at some point has an elastic and an inelastic range, right? So it has a inelastic range down here and an elastic range over here. And what these relate to at the end of the day is they relate to the total revenue curve and the fact that the total revenue peaks at that unit elastic point. This is the maximum total revenue possible for this particular firm. And so, if you have, the 2 points like we talked about earlier, we calculated the points for the goods so if we have this is 500, and this is 460. So these are the perfume bottles or whatever. And this was $9. That was $7. And so we saw that this was inelastic, right? Am I right? Am I using the wrong example? 0.333. Yeah. So the elasticity for this, we did it earlier, was 0.333, so it's inelastic, right? And so what happened when we went from $7 to $9? We increased the price, but the demand didn't decrease that much, right? The demand decreased by less than what the increase was in the price. And so, we're actually going to check this, but what happened was that we went from a total revenue that was right here to a higher total revenue over here. How would we check the total revenue? What is total revenue? What's the formula for total revenue? Total revenue is equal to, if we were running a lemonade stand and you sold 10 lemonades and they were all $3 a piece, what would your total revenue be? 30, right? Because it's 10 lemonades times $3 each. So it's my quantity times my price, right? So what's my first total revenue? 500 times 7, right? TR initially is 500 times 7, which is 3,500, right? And then what's my second total revenue? It's 460 times 9, which I don't know that offhand. 4,140. Which is more than 3,500. How did I know that? It's not like some magic or memorizing it or whatever, right? I knew the relationship between the elasticity and the total revenue curve. And so the total revenue curve, it looks like, half of the McDonald's arches. And where the arch is peaking is the point of unit elasticity. And so if I'm in the inelastic range and I'm increasing my price, so I'm going closer, right? I started over here and then I ended up closer to that unit elasticity point. I know that I'm going higher up on my total revenue arch. So we can always prove it to ourselves by doing, what's the old total revenue, what's the new total revenue. But what I want you guys to start developing is this intuition for, if I'm in that inelastic range of the demand curve and I increase the price, I just know that means my total revenue increases. So alternately, right, and so we'll start with this in class on Thursday. If we're in an elastic range, what would we have to do to increase the total revenue? Decrease the price. Very good. Awesome. Okay, cool. So this should wrap up chapter 4 now. I'm going to start getting grades and everything in, so you guys will see that reflected by Thursday class. Yeah, send me any emails with questions or comments, like stuff you want me to go over extra. Yeah.
When did you say quiz 4 and 5 were due? We talked about
This week.
this week.
Yeah.
At the end of the
I
week.
sent you an email.
Did it not change?
No, it said
No,
that
it's
it's
still
an application on it.
Yeah, don't worry about it. So if you did it, awesome. I'll give you an extra couple points or something, but if you don't worry about it till this week.
On Tuesday next week, our law class is going to the court.
Uh-huh.
And depending on
Yeah.
when we're done there, I'll be.
That's fine. It's with
It's right before this class.
who's the teacher though?
Leash, the set leash. So
Is she gonna send an email?
I don't know, but that's.
Just send an email to me if I don't mark you as friend.
Yeah.
You too?
We'll get the video.
Did you bring another couple decks?
I did.
Sweet.
I gotta earn some points there.
Let's do it.